Good morning, students. Today we're going to learn about cosecant graphs. You excited? Great, let's get started. Okay, so more specifically, I'm going to show you how to graph this graph. Y equals negative 3 cosecant of 2 theta plus 1. So let's begin. We're going to take this step by step. So let's just start off with the regular y equals sine of theta. You guys should know how this graph is supposed to look based on the unit circle. You guys remember the unit circle, right? It has a period of 2 pi and it has an amplitude of 1 and it starts off on 0, 0. Simple. So, what would happen if we added a 3 in front of the sine of theta? Well, it would multiply the amplitude by 3. So now it increases up to 3 and decreases down to negative 3. Other than that, it's pretty much the same. But what if we made this 3 a negative? Well, now it's basically a mirror image of what it was before. It decreases, then increases, then decreases. But again, the points are that the amplitude and the period are the same. But what if we put a 2 in front of the theta, separating the sine from the theta? The 2 acts sort of like a fast forward button on a VCR. It makes it so that we reach the period a lot faster. So with the 2 in front of the theta, it decreases the period by twice as much. So now instead of the period being at 2 pi, it's at pi, as you can see. At pi is when it starts to repeat. So that's what the 2 theta does. But what would happen if we added a 1 to this equation? Just added plus 1. Well, this is what would happen. So now the midline is not the x-axis. It is 1, as you can see. We basically took the whole graph and moved it up by 1 unit on the y-axis. As you can see, it's the same. It's just on the 1 line now. Alright, so after all that, we finally get to negative 3 cosecant of 2 theta plus 1. So when I graph cosecant graphs, I like to draw the equivalent sine graph in dotted lines like this, because it's not going to be the actual points of the cosecant graph, but it's a good outlier for where they are. So basically, cosecant is the inverse of sine. Cosecant equals 1 over sine. So because it's the inverse, by definition, it's basically going to mirror the sine graph. So for points like these, it's going to mirror. It's going to go the other way, like that. And it's going to do that for all of these points. At all the maximum and minimum points, it's going to be mirrored. But that's not it. So cosecant is 1 over sine. Well, what about when sine equals 0? Well, then it's going to be 1 over 0, which is undefined. And whenever there's something undefined, you have to have an asymptote. So basically, whenever the sine equals 1, or whenever the x value, the value on the x-axis equals 1, there's going to have to be an asymptote, because that's when it's going to be a 1 over 0 fraction and it's going to be undefined. So all of these points where there's a dot on the 1 line, there's going to have to be an asymptote. So that's a lot of asymptotes, as you can see. And now that you know that, you can graph the cosecant graph because you just draw these points going up. They can never cross the asymptotes, but they can get as close as humanly possible. Congratulations! You just graphed y equals negative 3 cosecant of 2 theta plus 1. You should be proud of yourself. Great job, guys. Wasn't that fun?